Alright, so how do we find the length of a vector in more than 2 dimensions? Okay, what if we have a 35-dimensional vector and we want to find the length of it? How do we do that? Okay, well, I'm not going to write 35 letters just for an example, but I will give you something that applies to any number of dimensions, okay? And it's very similar to the Pythagorean theorem. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. Okay, and therefore c is equal to the square root of a squared plus b squared. Right, so how do we extend this to apply to vectors that are more than 2 dimensions? Let's say we have a vector v, and we want to find the length of that vector. Okay, the 2 bars on each side just says that we're looking for the length. All we do is extend the Pythagorean theorem. It's pretty straightforward. So now we can just say x1 squared plus x2 squared plus x3 squared plus xn squared. And that equals our vector length, okay? So we're just extending the Pythagorean theorem to include the other components that are above just the first 2 dimensions, okay? Now what if we want to make our vector here equal to a length of 1? What if we want to make it a unit vector? So all we have to do to make our vector length 1 is divide our vector by the vector length. So we could say the vector v divided by the length of vector v will give us a vector of length 1. And that's equivalent to saying that 1 over the length of vector v times vector v will give us a vector of length 1. But why does that work, okay? If we have a different vector, we'll call it a vector y. Why not? And then we have another vector 2y. 2y, we know is just twice the length of y, but it points in the same direction. We're just adjusting the magnitude, right? So all this constant here does is adjust the magnitude of the vector v to make vector v only have a length of 1. So I know that's a bit of a short one today, and I hope that helps. And good luck on your test tomorrow. I'm sure you'll do great.